I don't think that I can fairly say that viceless woodworking is better for anything other than cost unless I directly compare it to a vise setup. So I built a $25 workbench around that idea that was small enough to use in the dining room of my apartment for the winter. It's a hybrid of a bunch of different designs, and my original intent was to show off building something very robust with minimal tools, although as we'll see later, that turned into showcasing as many techniques as I possibly could. Here we have a skirt on two sides, the other end is a tail vise, and the last side is left open for reasons we'll discuss later. If you don't have a free quick release tail vise on hand like I did, you can make yours fully symmetrical and do without, because I worked without a vise for many years and I did just fine. Now to go get some 2x4s and some 2x8s. 8 and 10 feet long respectively, and boy do we have our choices cut out for us. There's many pallets worth of boards out there, so you can take your time and find the best ones with knots not on your cut lines, boards like this that don't have pith running through the center because that pith makes them curve and warp much worse and can introduce a risk of cracking. Also check all of the sides because there might be a hidden knot in there. While it's strictly not the end of the world, I prefer having clear boards, just because that way there's a guarantee that a knot like that is going to be cut out as part of the joinery rather than just problematically in the way. It's much more important, though, to check for straightness because that's going to reduce the amount of flattening work that we have to do. There's also plenty of cases of tear out like that, where there's a branch or pith that's running through the edge of a board. This board right here looks pretty clear all the way around, and what problems it does have are mostly just the staining that it has from its environment, which can plane out in 1 or 2 passes pretty easily. This board is also pretty good, because while it has small knots on it, it's overall pretty straight. You can look at it there, it's not bowing or cupping too terribly badly. And it's also important to check every side of something, so I'm here checking down the edge and sighting down the other edge for any kind of variation up, down, or to the side, and then I drop it despite it being a winner. This board right here was incredibly tempting because it didn't have any of the knots that I was trying to avoid, and in retrospect I'd probably still pick one that has tear out like that and just put that tear out piece on the inside. Anyway, here's the boards that I did pick, and I should have tried a little harder because there were some bowing problems introduced later on. Anyway, on to measuring. I personally like a higher workbench because you can always chop some off the bottom if it gets too tall for you and you find that it's consistently too tall, but if it's too short then you're just stuck. So here I am trying out a bunch of different motions that I plan to be doing quite a lot, and what I settled on is that I want the top of the bench to be approximately the top of my belt. Next I looked over the ends of my 2x4s to see which ones were smooth, if any, and which ones were rough cut. I'd rather have the rough ends facing down on the legs rather than being exposed joinery. If you happen not to have a measuring tape, then go buy one. What are you doing? But if you don't want to use a measuring tape, you can use one of these folding rulers. This one's my grandfather's, and it's aluminum. There's a couple advantages to these, notably that if you slide the ends past each other, as I'm doing here, you can use it as a depth gauge in addition to the regular measuring tasks. It's not as perfectly accurate the way that a measuring tape is, because it doesn't get down to the 32nd, but I find that perfectly serviceable, and that extra little advantage might be something that you're interested in. It's a cool old tool worth remembering. And speaking of cool old tools, seeing all the things that you can do with a Japanese square has made me want to try my hand at one of these angle squares, which is the closest equivalent that I can get access to. I used an offcut of 2x4 to make this little angle block, which is helpful for a number of operations, mostly because this edge here where those two cuts meet, while it's not perfectly square to itself, both of those faces of it are perfectly plumb to the reference face, which is all you need for the edge where they meet to be perfectly perpendicular to that same reference face. My primary usage for this thing is as a drilling gauge, but it's also very useful as a way to get over the rounded corners of construction-grade lumber. To use it as a drilling gauge, I butt it up against the drill like this, and then tilting the drill back and forth, you can see when it's going to strike the faces there. When I'm going for absolute precision, this is my new process. I'll make a little mark with my measuring tape and a mechanical pencil. I'll line up the square to that mark and making sure that the far side of the square is dipped down into the middle of the edge that I'm referencing off of. I try to use the long side to be the referencing side, because that way it'll make sure that it's the most square to the most of the edge as I can. Then I'll use my right angle block to transfer that line around to the other edges. I'm not transferring the entire line, I'm just making a little bit of a mark that I can catch with my square, because my square is going to be more accurate than my right angle block. It just needs to be on the same plane to within the margin of error of the thickness of the mechanical pencil itself. This is the edge that I just referenced from, and this is the edge that I want to do next. So in order to do that, I have to reference from where my square already was. That way it minimizes the total error. And the same thing applies to the opposite edge. Keeping track of what side you just referenced from and where you need to reference to next in order to maintain accuracy all the way around might seem like a lot of extra effort to go through and things to manage, but after you've done it like 3 times, then it just becomes natural, and now this is how I cut basically everything. Yeah, that wound up pretty dead on. Gotta say I'm pretty pleased with that. Now, because this is my original reference corner, in order to do the far side, I have to do the face that was shared by that side. If you've kept track of your references, then the error doesn't get a chance to build on itself very much, and so the lines that you've drawn should meet exactly on the corner without you having to try. Like that. I started out by trying to cut into all of the corners and connect those lines, which was a decent process, but I managed to find a better one later on. Here you can see me struggling with a cut and then using my finger as a bit of a fence to guide it. Because my nail sticks out a little bit, or the curved part of my finger is curving away from the teeth, I don't actually cut myself as I'm doing this. That's just enough to get me started, and then watching the reflection, like this, helps keep me on track. The edge should form a straight line. I'm lifting up right here for better view and access, but this is a pretty advanced technique, so proceed with caution. I'm also trailing the finger over the top for extra precision, in the same way that you would a Western saw. When I connect a corner to the one below it, all I actually do is come in a little ways and then change the angle to cut down only a single face. All I have to do is keep the saw moving as I change that angle, and it will be very easy for me to keep on track and in plane. Then when I have a good-sized kerf, I use that as a guide and change the angle again and cut the top face, before using that extra kerf as a guide to drop the line even further. I have a kerf run around all 4 faces now, and a technique that I find pretty easy to use as a beginner, or if I am getting tired at that point, is to cut slightly less than halfway in from both faces, and then where the cut meets in the middle, saw that down. Now if you did everything right, it should come out pretty square against your framing square from all the directions that matter. But if you want to give it its ultimate test, the best thing that you can do to prove it is to see if it stands under its own power on your uneven floor. That looks pretty darn good. I repeated this process until I had all the legs and stretchers done, and then moved on to the top and skirt boards. Now for those, I had to use the short arm of my framing square as my reference arm, and then draw using the longer one, because that was the only one that could actually reach all the way across the boards. To make these cuts a little more comfortably, I had to get lower, which means no more using the stool I was using to make my layout more comfortable. Here you can see that my cut has run all the way to the far corner, and I'm pivoting on that corner to drop a very long cut line, which is how I'm staying so precise. You can see this corner has some pretty bad tear out, but I can use my right angle block to jump over it entirely and transfer the line. The scalloping on that edge also makes a good demonstration of the advantage of the framing square. You see, as I'm rocking back and forth here, it is catching on 2 high points here, but if I rock it the other way, these 2 high points are much further apart, which adds up to a more accurate line. I used a dowel as a spacer here so I could get the total width of the bench top so I can measure the short stretchers. These gaps here allow extra room for flex and a couple of other tricks that I'm still figuring out. It wound up being 22 inches exactly. Here you have my 2 marking gauges that I use for the rest of the layout. The one in the back is a copy of Rex Kruger, and the one up close is from Chuansheng Shin, I think is how you pronounce that. I made it using my right angle block to drill pilot holes for each of these 2 nails to start, and then after driving those nails in, I sharpened the heads of those nails and used them kind of like a round cutter. You can adjust them very easily with hammer taps, either a large one for a large motion or just a gentle tap for a small motion. It has a huge reference face, which makes layout a breeze. Now for the French pattern I stole from Rex Kruger. You can see I've got a little dip so that the cutter can sit exactly on the reference face, and I'm using a screw because it's hardened. I find it very easy to just over adjust it, push it into place, press the lock on it, check, and then give it a little extra bit of a tap to get that final bit of adjustment to make sure that it's dead on precise. Then give it an extra tap to lock it in extra secure. Now to reference extra accurately, you have to look at the growth rings, which you can see by looking at the end here. You can see that most of them are going this direction, and those lines are going to want to straighten out as it dries, meaning that side isn't going to be perfectly flat, it's going to be smiling a little bit. And then the opposite side is going to be cupped the opposite way. That means that this side should be the one that we reference from if we're trying to drop a perfect perpendicular, because that one's the closest to being already pretty flat. Which is also why I use that side to reference when I'm gauging it for thickness to take half of it out. I set the cutter to the full thickness of the leg, scribed that onto the skirt board, and then laid out the skirt board for a half-lapped dovetail. Because of the way I'm going to be laying this out, I can just pick an arbitrary spot and draw a line at some angle that looks vaguely like a dovetail, and then use a finger gauge to transfer that line straight down. In the future, for these cuts, I do use my square, but it was easy for this first one to just start cutting. As long as I don't go over my scribe line, I'm fine. If my cut wasn't perfect, I would clean it up with a chisel, but it happens to be nice and square all the way down the length of that cut. So then I just mark it for half lapping and then cut that half lap joint. I use my chisel in the scribe line to make that a little bit deeper, and then I come in at an angle to make a little trench for my saw to sit in, which I then use to saw down to my half lap mark. Sawing out the rest of the waist took quite a while, but I'm actually surprised at how clean the results were. It didn't wander really at all. It left the cheeks very nice and square. Unfortunately, it was too slow, so I decided to see if I could split it out using my hatchet, and to use my hatchet as a receiving mallet. I rapidly determined that this was a terrible idea and that it would be super dangerous, and so I switched to a framing chisel. That was loud, but it was a lot faster, removing a huge amount of waste with almost no effort on my part. Other than, tearing it out. See, look how thick that chunk is. Splitting it out didn't leave the cleanest finish, though, and you gotta watch the direction that it's gonna break, so I wound up using my thinner chisels to clean up all of that and make sure that it was good and square. I did this in a couple of different methods to see which one would work. I used my engineer's square as a depth gauge to run that all the way across, and that worked pretty well. And I was also able to get pretty good results by using my nail marking gauge. Anytime that it lifted up as it rode over the surface, that was a spot where it wasn't flat enough. This one wasn't as good, but it was pretty good at marking out where the worst spots were. You can see it hang up there. And I can use it kind of like a router in some spots. From here, I set the skirt board very carefully to the legs and mark the cut lines, and then use my nail gauge again to scribe the depth line. I just start cutting as long as I stay straight at there, and then only go in about 1/2 inch and use my framing square to mark it the rest of the way to the depth line on both sides, and then finish my cut to the depth line, and then rip cut the rest of that out. Now you can see here that the half-lap dovetail joints that I just cut don't really match each other very well, but because I measured and cut accurately, and because they were measured directly off of the piece that goes into that socket, it doesn't actually matter. You can still get a tight fit, as I'm demonstrating right here. Next, I squared them up to each other again, and marked a line square across to be the top edge of the stretcher, and then set those the correct distance apart, and marked my stretcher board's half-lap dovetail joint. Here you can see me remove a knot from the stretcher before I cut that joint. It was going to catch on my pant leg all the time, so I decided to make it as rounded over and smooth as I possibly could, and it winds up being a nice detail. It doesn't compromise the structure. Laying out the long stretcher was a little fiddly at first, but it wound up being a pretty convenient working height as long as I could hold all the pieces together. Now, if you're keen-eyed, you might be able to see a problem emerging already. That is, that there's a little half-lap out there that I'm not considering. I'm not leaving enough space for that. So that means that I have to nip about 3/4 of an inch off of my skirt board, and then that would also throw off my cut line. The angle on the dovetail is still correct, but it's not wide enough to fully fill the socket, so I have to cut a spacer for that to make up the difference, and then pare it down until it fits perfectly. Here I am cleaning up the joint for gluing, and then making sure that my spacer piece is thick enough and marking it for length. Then in the most fine precision work I've ever done before, I find the angle that I cut that with my bevel gauge, transfer it to the edge of the spacer, darken up that line, use a finger gauge to transfer that line across both sides of it so that it's the exact right edge length on both sides, and then clean it up with a chisel until it is the exact right angle all the way across. And you can see here that it fits perfectly in place with no gaps. And it's thicker than I need it to be, so I can trim it down. Now, standard yellow PVA wood glue is water-based, so in order to make the bond a little better, I put a little bit of water on both of the mating pieces, spread it out, and let it soak in. That way it'll draw the glue into the wood better than just putting the glue on directly. Then I put a pretty thin bead of glue and use the mating pieces to spread that out. And now it's time for my favorite clamping system ever. I took 100 feet of cotton clothesline, which you can get for about $3, and I rubbed it all over with beeswax so that the glue wouldn't stick to it. And then this right here is a 20-foot section. I've got a couple 20-foot sections and a couple 30-foot sections. So I'm spinning the end around back upon itself to make an adjusting eye, and I'm pushing that into place. And now here's just the part where it's cotton comes into play. See, cotton has a little bit of natural give to it. It stretches. And if you do a couple of loops where that stretch is in place, then that will add slowly multiplying additional tension to the clamping force. So a couple of loops around and then tie it off, and you have an any size clamp that will hold irregular pieces nice and tight for the duration of the clamp. You can take the clamps off about an hour later as long as there's no internal tension in the joint, and just let it cure for the next 12 hours or so by itself so it can come up to full strength. Then I use a chisel to trim it down to a perfect fit. And over here you can see an error in layout that I made. Make sure that you're careful with what you're doing because while this one wound up not being super critical, future-ish errors may not be so kind. Now, there's a question of what to do if your long cuts for that half-lap dovetail socket to enclose some knots. Well, I ran into that problem, and I made a series of cuts about 1/8 to 1/4 of an inch apart through the knots, and then was able to chisel them out with a framing chisel, and you have to approach this very carefully and to control your split. I'm a good 1/4 of an inch away from my intended cut line there, and I'm slowly removing these pieces out. The short distance between the relief cuts makes it so that if there happens to be some tear out, it doesn't propagate too far, like too fast, so that I can still control it. If there happens to be a bit of a dip in this particular joint, it's not ultra critical, but it might be in the future. You can see a couple of pieces are just leaping out there. That one was bad. That one was unsupported, and I should have attacked it from the other side. It wound up being okay, but that's purely by happenstance. I got better at this in the future. You can see that it went just slightly above the cut line there, so I was really lucky. Not quite so lucky here, but that happens not to be a critical failure. That's the kind of issue that I can live with. Now, there is still the problem of the cuts through the knot not going deep enough. So, as long as I was careful not to exceed my depth line, that was an easy enough fix. And then a nice, sharp, thinner chisel that will encounter less resistance took that out. A lot of this stage of the cleanup was going slow and planning my cuts around where the tear out was going to be and what the grain direction was. But eventually I was able to just go back to cross grain splitting. My fit wound up being so precise that I had to use a safety spacer and a mallet to tap it into place, which means I did a pretty good job. Because I want to be able to swap out parts or to knock the whole thing down for storage if necessary, I'm using nails to hold the joinery together instead of glue. Here I'm using a nail as an awl to the layout of where those pilot holes are going to go. Then I size my gauge to the thickness of the nail and find something that's just a little bit smaller than that nail so that the nail itself has a good amount of meat to grip onto. Most of my design for the whole workbench is vaguely stolen from Richard McGuire, reconstructed from a couple of photographs on his website. So I'm using nails for basically the same reason that he does, which is that they flex when the wood seasons. The nails on the stretchers don't actually gain anything by being perfectly square and straight, so I'm just eyeballing them square and drilling them in by hand. You can see that if you get along this angle, you can more or less keep yourself straight to the leg. I also came back and countersunk these a ways so that the head of the nail would be able to sit fully beneath the surface of the wood. That way, if I had to flatten it, if I had to clamp something against it, the nail isn't going to get in the way and cause any problems. The piece that the vise was going to mount to, I cut 1/4 inch long because there's not a whole lot of meat on there for it to grip onto. So I wanted a little bit of a shelf that I split out right here. That is the whole length of the leg, so that I could use that to take the weight of the piece just a little bit, just to offset the narrowness of the gripping point. Then I used my rope clamps again, this time with a trucker's hitch, to make sure that everything was seated nice and firmly into its final resting positions, so that when I drill the pilot holes for the cross piece that takes the vise, it would go in nice and clean through that leg all the way without deviating too far to one side. Then I took the clamps off and sank the nails, because otherwise the rope clamp would be underneath the frame as I'm doing it, and that would bruise the wood. Now, up until this point, I'd been using 6-penny nails, which are pretty long, and I don't want to go all the way through the back of the leg when I go through the short side. So I'm using 4-penny nails when I'm going in this direction. This also means that I don't have to countersink them quite as much, because you can just pound them a little harder and they'll go in a little better. Because of how much thinner these nails are, I'm also not bothering to pre-drill them. I'm just pounding them in straight away because I don't think it's going to cause a crack. I was inconsistent with my placement of the nails to try and figure out what the best way to place them is. They're always off of perfectly vertical from each other, but I'm not sure if it's better to have the nail close to the inside corner of the dovetail or whether I should have them further out. Which one would be more stable? I'm not really sure, and I'm planning on the performance of this workbench telling me more about that as it goes on. From the photographs that I based this design on, I'm pretty sure that what you're supposed to do is put them to the inside of the dovetails, but as to why that is, I guess we'll figure out in a couple months. Anyway, after both tails were fully assembled, I put the long stretchers in one at a time, feddled them a little bit, then pounded in the nails and set them nice and deep. Now came the worst part of this process, which was dealing with the vise. I did not totally understand the mechanism of the vise at first. I didn't know that it was a quick release vise that I had been given, which caused some problems and confusion later on. The first thing that I had to tackle, though, was disassembling it so that I could clean the whole thing and make sure that it ran smoothly, which involved removing a retaining pin and then unbolting the thing from the piece of wood that it was attached to. The retaining pin had been bent over and then rusted in place, so getting it out was a multi-hour struggle, and eventually I just gave up, cut through it, and then filed it flush. So that'll be a problem for someone in the future if you actually want a retaining pin. Yay. I did give it a good try with a bunch of rust looseners and solvents and things, but nothing actually worked, so I think this was really my only option. And speaking of rust looseners, how about that cleaning process? Not really having a tarp or anything, I took some spare plastic bags from grocery shopping, tore them open, and used that as a padding so that I wouldn't get rust all over my floor. I'm not normally this ginger about getting rust and oil and stuff on my hands, but I was going to be at this for a very long time, and so I decided that some gloves would make cleanup a little faster, because cleanup is really the worst part. I guess this rust removal technically counts as cleanup? Yeah, cleanup is the worst part. In some particularly badly rusted places, I used vinegar to eat through the rust, and then had to wash it multiple times to make sure all the acid was out, otherwise it would just continue to corrode. Then most of the cleaning was done with some turbine oil and steel wire brushes. Brass brushes in a couple of places. Actually mounting the vise was probably a more complicated process than it needed to be, but here's how I did it. I divided the whole thing in half and then used that halfway mark that I transferred around the sides to line up to a corresponding line that was perfectly perpendicular to the board that the vise was going to be bolted into. Then I marked the holes for the bolts. Then I converted each of those circular marks into crosshairs so that I could line up my drill bits very accurately. For extra precision, I also have a square awl that I made out of a screwdriver. That will keep my drill heads from wandering. Correctly sizing the hole for the drill bits is a bit of a fiddly process. It's a lot of guess and check. You want the shank of the screw to be fully behind the drill bit, but the threads to be poking out. Once they're about like that, where you can see that it's poking out a ways, use the right angle block to line it up perfectly, square her down, drill in, and make sure you're over a dog hole. That way, if you happen to blow out the other side, it isn't really a big deal. And after that went astray, I decided to drill a pilot hole like a smart person. So I just picked any smaller bit that I was confident of and drilled it in square. Because of the height of the chop of the vise, getting it installed was a bit of a fuss, but just propped it up with some blocks and then had at it. After installing half the chop, I realized that one of my top boards was not perfectly flat. It had a bit of a twist in it, so it took a while to plane that out, but eventually I got to the point where I was deciding what boards went in what place. I put the boards on the top so that the side that would cup in the future would be facing down. That way, there'd always be 2 points of contact per end as they acclimated further to the environment. Then I flipped them around until the truest parts were in the places that I expect would get the most use. That way there would be less adjusting over time as they weathered. I marked, drilled, and nailed the boards in place. Maybe I was a little too hasty though, because one board was out of alignment, so I had to pull the nails out very tediously and be more careful to ensure that it would form a flush surface with the skirt. I set one nail in that I knew was in the right spot, and then I used a ruler to pivot the other end into the correct place. Now back to the vise. I don't necessarily trust just those 2 bolts to be able to support the weight of the vise and the work and the force of chiseling into it and whatever else I'm doing. That's a lot of weight to be putting on just the threads. I'd rather have the force being caught by a screw that's perpendicular to the force being applied, which means that I need a spacer. And since the gap between the bench and the chuck is more than 3/4 of an inch, that means I need to take a bigger piece and cut it down to the size and slope that I need. The depth of the chuck here also happens to be the same as the width of the scrap boards that I have laying around, so this seems like a great opportunity for soft jaws. Now my original idea was to have screws that ran through the soft jaws and then into the body of the workbench to also be the support. This wound up not working out on the day, but I'll revisit the idea sometime soon. Now for the spacer, I put that cup side towards the workbench so that it would register neatly, and then just traced the curve because it wasn't perfectly straight on the inside of the chop. After splitting out the bulk of the waste, I used my carpenter's hatchet to clean up the rest of the surface in the style of a Japanese spear plane, or yarikana. With the amount of material that I had to waste out, I found it easier and faster than using a plane because of the control around knots and tear out. Maybe that's because I didn't have a scrub plane at the time, but even now that I do, I'm still going to keep this trick around for sheer versatility. My left hand controls the pitch, and my right hand both keeps it straight and supplies the power by changing the sweep angle. I can do a whole video on this technique, so I probably will at some point. You can take out big chips or fine shavings just by changing the angle, and it can leave a surprisingly flat surface if you're careful. You can see that the narrower sweep produces tighter curls and thinner shavings. Not phone book paper thin, but a sharp blade will leave a smooth surface regardless, and you should still finish it with a plane if you're going for dead flat or if you're jointing an edge. Dialing in the final fit was also a pretty simple process. Just push it in until it leaves a black mark on the wood, then remove the wood that has the black mark on it. Repeat until it fits. I marked the holes the same way I did for the vise bolts, getting some nameless goo on my pencil in the process. Gross. Then ran one screw to get the basic position and the other two to lock it fully in place. All three screws needed the ratchet function of my brace to drive into place in this position. I used the edge of my right angle block for alignment. I countersunk the screw holes with a spade bit and put the vise back in. And here's where my vise problem began. You see the writing on that chuck right there, how it says front on it? That should be facing up when it's installed and upright. Facing it up now means that it will be upside down later, and turning the screw to tighten it will cause the threads to disengage and the whole thing will just spin in place. What's supposed to happen is you loosen it by half a turn to make it quick release, and then you can slide it open. Then when you turn to tighten, it engages the threads and closes it. This makes for a pretty convenient system since loosening the jaws makes it slide not only open, but closed too. Easy to resize or get stuff in and out. My other problem here is that the screws that I was going to use to hold the soft jaws in place aren't actually long enough to meaningfully bite into the spacer. Since this was made, I found the screws I was originally looking for, but there was an innate flaw in my plan. You see those little holes to the outside of the countersunk ones? Those are the ones for mounting soft jaws, and I don't have screws that match the threading that they have, and until I do, I set these aside because they're perfectly sized and flush and everything. I also drew a dopey monster face on them to highlight that they're jaws and not just random scrap, even though it would be pretty easy to cut new ones. Maybe I'm sentimental. It also marks which side stays stationary and which side moves, visualized by the way that the mouth would open. Take every chance you can find to be whimsical. The next problem was one of the top boards twisting up after it was set in place. I used my framing square to mark out the material to remove, then I ran my square down the board until I saw it go flush. Putting the corner of my square on that spot to mark it lets me see, and then mark, the triangle of material that needs removing. I tuned up a scrub plane for it that I'll discuss some other time. Putting a spacer in the gap underneath had a couple of options of how to solve, and here's a few. I started out by trying to copy a trick from Mr. Chickadee, lashing a pencil to a pair of dividers to trace the shape onto a pattern. I started with a clove hitch, wrapped tightly a few times, and then threw on another clove hitch in the middle to maintain my tension and kept going, finishing with another clove hitch. I don't usually like clove hitches, but it's fast and simple and easy to demonstrate on camera. The magnetic tail cap of my flashlight gave me light to work, and a line I marked square on a scrap piece visually registered against the rail. I tried tracing the way that Mr. Chickadee does, and then I gave up and let the thickness of the pencil be my spacer. Marking true square onto both of these attempts, I used these as a target point for the thin side of the wedge that I was going to fit into that gap. I used a chisel on my split bench hook for the rough shaping and then tried to pull it across my plane to dial in the thickness precisely, before quickly giving up on that and using my bench hook as a shooting board. I'd never used a shooting board before, so it was a bit fiddly at first, but the design of the Chinese planes that I use was a big help in settling into a rhythm. The crossbar works as a very convenient handle that you can adjust to either side depending on your handedness or what the task calls for. The bench wasn't even done yet, and already I was feeling how natural it is to work from any side as it suits me. I tapped the board up slightly, put the wedge wide side in first and drove it home, then pounded the board firm again so it bedded properly against the wedge. One of the things I really came to appreciate about this project is the sheer number of techniques I was able to demo. Stuff you don't see anybody talk about that are clever inventions of the past nearly lost. I used a combination of them in laying out the holes for my bench dogs. I want a checkerboard pattern of them running down the length of this board on the line that divides the quarters. So to take a tip from Paul Sellers, I put my square across it so that the 0 and 12 are exactly on the edges. Then 3 and 9's marks fall exactly 1/4 of the way in, and the 6 will be exactly on the halfway. I do this on both sides, and then I connect the corresponding marks by stretching a piece of twine taut between them. This layout method is what they did before the invention of the chalk line or the ink line, and it's a technique that I got from pre-industrial masonry and architecture layout. There's lots of really cool stuff out there. I'm using masking tape because I have an abundance of it, but you can just as easily hold them in place with a book, a plane, or an unsuspecting helper. I'm placing my twine so that the exact border between light and shadow falls across the intersection that marks the line. An intersection like this that marks out from the straight edge is better than an ambiguously sighted tick mark or an X. Then I make little marks along the border of light and shadow all the way down the line, about 2 palm spans apart. This way, my straight edge can have at least 3 marks to register to, and my margin of error can be about the thickness of a pencil line. But where along these lines should I put my dog holes if I want them to be evenly spaced? Here comes the great advantage of switching back and forth between measurement systems. The total working area between the inside of each leg is 41 inches, and that sucks to divide. But it's also 104 centimeters. Come in 2 centimeters from each side, and I can put a dog every 10 centimeters. Easy. And since I'm staggering them, I'll come in 5 more centimeters from the edge and mark the middle row. I get exactly on the mark as I can with a square awl and push. A note about actually drilling the dog holes before I continue with the layout. I'm making 3/4 inch holes, so I'm going to want a pilot hole for that. But for the main bit, I have some options. In the past, I just did my dog holes with this speed bore bit, and the hex shank works fine in my brace and bit. It's very fast, but the inside of the hole is a little too rough for my tastes these days. The spade bits are cheap for a full set, and you can sharpen them a ton with just a smidgen of patience, but I find them to be pretty slow going, even though they perform pretty well when they're properly sharpened. They were good when I was starting out, but I've moved on to this role of old-timey augers. This is where I'm breaking the rule of using cheap tools, and it's purely because I like the way that they feel to use and they leave a clean hole. You can find pretty complete sets on eBay, or put them together piecemeal from flea markets and antique malls, but it's by far the most expensive thing in the video at $35 for the set after haggling. You can do this whole project just fine with a single 80-cent spade bit in the size of your choice. Don't take this as your only option. Once I have a bit selected for the pilot hole that's smaller than the base of the snail, we can move on. Next up is the layout on the skirt. Similar process, but with its own set of challenges. And advantages, since my pocket measuring tape easily crosses the whole 22-inch tail and I don't have to bother with twine. Coming in an inch from the inside of each leg leaves me with 17 inches, which initially seems like a mess to subdivide, but 17 might as well be 16, so I can space them 4 inches apart and tack on the remainder again in quarters. Then add half of that to checkerboard offset the middle row again. Very clean. I tried to clamp my right angle block to the skirt for alignment, and it kind of worked, but it was risky. If I tilted astray even slightly, the edge of my bit would chomp into the right angle and damage it, which, wonder of wonders, is exactly what happened. Time for a more creative solution. The honeycomb lens of my flashlight produces a diffuse field of light that's larger than the diameter of my drill bits. Wood not being magnetic, I had to get creative with how to suspend the light in a way that would work, relying on our old friend the taut line hitch to control the hanging length. With the light hanging directly on the line, the shadow cast by my drill bit comes to a point on the layout line. Changing the pitch will move the point of the shadow off of the line, exaggerated here for the camera, and I can visually keep it straight in a left to right way. The camera can barely cope with the light, but I put the drill on my chin for extra stability. I also use this technique to rapidly process the pilot holes for the top. Set the drill in the awl mark, use my right angle block to line it up square, visually check what the shadow looks like when it's square, and then full steam ahead. I trust my pilot holes, but if you don't, then here's another option. Take any metal ring and put it over the bit. You can visually keep it square in a left to right direction, or at least build the skill to do so, and if you deviate from a perfect flat pitch, the ring will drift forwards or backwards. When you see it drift, adjust to correct and keep it in the middle of the shank. My right angle block here shows that it's perfectly square in all directions. If you have good posture and a steady hand, you can skip all the extras by just registering the pilot bit to the right angle block when drilling, and then screwing in the brace up until the spurs hit the surface, and rechecking with the right angle block before continuing. It doesn't look perfectly square here, but that's just an optical illusion from the camera not being perfectly level with the hole. It's worth noting that I only went until I could feel the snail from the other side. Then I drilled from the inside out. The ratchet function once again did me great favors here. I could have saved this headache by just doing my dog hole layout before I put these boards on, but what's the challenge in that? Doing things purely because they're hard instead of applying an ounce of forethought is totally what smart people do, and so is admitting their mistakes. The middle board is only going to have dog holes in the center row, but because of the tail that the vise attaches to, the shortest board that I can clamp while using it as a tail vise is 8 inches. I don't really see that as a problem though, since the chop of my vise is 10 inches, so anything that I would want to use the vise for that's that small is probably something I'd put in the vise horizontally anyway, if I didn't use one of the viseless solutions. The dog holes on the skirt side of the top present a different challenge. The width of the hole just barely doesn't clear the skirt, and if I put a dog up next to it, you can see that there's no room for my hand actually putting the thing in and out. I move it a bit to a comfortable place and I mark the new center. The speed square is a bit rough in its measurements, so I err on the far side of the tick mark, then do my layout in the exact same way as before, just putting the 3 mark on the new hole spot and marking the 6 and the 9. The skirt and open sides of the top won't have the same width apart as each other, but the holes are the same length apart, and I can think of a couple ways that I can use that to my advantage later, so I'll live with the asymmetry. Marking the skirt, I use a $1 corkback ruler, and wow does that grippy surface ever make a difference in how easy this is. I should have done this on the tail, seriously. Then I pull out a length of twine and I repeat my layout. This skirt matches the whole placement of the top lengthwise. My final touch is to use my framing square to make some alignment marks under each of the framed joints. There's nothing holding this together other than nails, and I wanted to see how that affects how it moves over time. 4 months later, this turned out to be the right choice, since I had to add these nails to this tail skirt to keep the lengthwise one from moving. It was only loosening at all because of how I yank on it when I'm repositioning it, which I consider a key feature of this bench. It wouldn't be necessary if I was more careful about that, but I patently refuse to be less reckless. I wound up doing the pilot holes for every bench dog, but after finishing the tail, I only completed the ones that I think I'm going to use the most. I can easily add more later, and this saves on the labor time. Doing it all at once would be a huge pain. Looking back, there's a couple of choices that I would have made differently if I was starting over. I didn't notice until I was laying out my dog holes that the picture I was basing my bench on had ribs. Bit hard to do that with an open side, especially since I want to put in the bird's mouth vise for my outdoor bench at some point. So I maybe would have turned one of the open side legs 90 degrees and put a stretcher rail on the inside for them to rest on so that the bird's mouth vise would still be doable. Besides, I have a couple other ideas for how I want to do a bird's mouth vise that don't involve chopping out a 4x6 centimeter block from your bench top, but that's for another video. Originally, the skirt was going to provide all the downward rigidity on its side, but the top board that went over it bowed as the weather changed, which defeated the point of building it this way entirely. For an extra $6, I can replace that board with one that was more carefully picked so that this won't happen, or I can just pull it out and flatten it, but I haven't gotten around to either of those things. Besides, just like working on an open side bench, I can do my hammering and chiseling near the legs. That's why those are the only dog holes I bothered with on the open side anyway. It also tips a little, and that is tipping, not racking. The framing of the skirt provides plenty of racking resistance, but the thing being light and tall and narrow and on an uneven surface means I have to keep 1 foot on from certain directions if it's in certain positions. But that isn't really too much of an inconvenience. The overall proportion is 3:2, and after this experience I made a little template to test different proportions for stability. As I said earlier, I might make it shorter to correct the issue and to see what working on a shorter bench is like, and maybe I'll do a video on my rotation trick. I think weight is overrated though. I prefer my bench light and versatile, and I'd rather rely on its geometry and rigidity for that stability. In the end, I wound up using basically every tool I had, which is the total opposite of what I set out to do. But you can easily build this bench with just what you see here. I already had the nails, and the vise was a gift, so the cost to me was $21 total. Since the idea is about not having to be confined into vise or viseless, screw or nails, push or pull. I dub this the non-binary workbench. Now let's add some kit to it.